All right, class. So last time we talked about conversion, right? And we talked about between the metric to metric conversion, and then time before that we talked about the US metric conversion. And the last thing I did, I gave you two take-home problems to do. Hopefully you did them. So let's go over the take-home problems and then move on to the next part. Now, what we talked about last time, every time you have a problem like this, what you're going to do, you're going to write down what's given to you, which is 20.5 ounces. Okay? Write down what's given to you. Now, what I don't want ounces, what I want is gram. So I'm going to put ounce over here, and what I'm going to put on top is gram, because then I can cancel out the ounces, and I'm going to have gram. That's great. And the other thing I told you I'm going to give you this conversion sheet. This conversion sheet has a conversion between the US and the metric system, or in between the US unit, okay? So we have a metric system, we have a US system. So if I have to ask you to do anything between metric to US conversion, or I have to ask you to do something in between the US unit conversion, you can use this chart to do it. Now, metric to metric, I put a table for you guys, and you have to know that table, and we'll get there in a second. Okay, so now here, this is between the metric and the US system. Now, this is great. Now, all I have to do is find out the conversion between ounces and grams. There's a problem. When you look at this, is there a direct conversion on this sheet between ounces and gram? No. I don't give you anything. I don't give you anything direct between ounces and grams. So you want to see what the problem is? So there's no direct conversion I'm giving you on this sheet between ounces and grams. So what that means is I have to be a little bit more creative. Okay? Now what could I do? Well, what I could do, I could go from ounces to pounds, and then I can go from pounds to grams. I can go from ounces to pounds, and then I can go from pounds to grams. I can do that. So sometimes you can't find the direct conversion. If you can't find the direct conversion, that's okay. You can still be creative and do it. All right. So I can go from ounces to pounds, and then from pounds to gram. Remember, to be able to cancel it out, they have to be on the opposite side, top, bottom. So ounces cancel out, pounds cancel out, and I end up with gram. Now I can go back to the chart and look at the conversion. What's the conversion between pounds and ounces? 1 pound is 16 ounces, and 1 pound is 454 grams. You guys are following me so far? Okay. Nice job. Now that we got this part down, now what we have to really care about, we have to also care about the significant figures. How many sig fig is this one over here? This one over here is 3 sig fig. Okay. What's a sig fig over here? There is no sig fig, and there is no sig fig because conversion factors, they do not affect or sig fig, because these are not something that you measure. It's just conversion factor. We don't consider them when we decide on sig fig. This is 3 sig fig, so my final answer is going to have 3 sig fig. Now, I want to make sure you know how to use a calculator. You have your calculator out? Let's do this together. 20.5 times 1 times 454 divided by 16 divided by 1. You multiply everything on top and you divide it by the bottom. If you do that, what you end up getting 581.6875. Okay. Now we said how many sig fig we need. We need 3 sig fig. So we need to round this to reflect that. This number is 6, so I can round up. So my answer will be 582 grams. Don't forget to put the unit next to it. So far so good? Okay, beautiful. Now, again, this chart that I've given you is between the US unit, any conversion between feet, inches, miles, feet, anything in between the US unit, and this part on this side between the metric and the US, centimeter to inches, for example, kilometer to miles, and this will be given to you, so you don't have to memorize it. Now let's come over here. Here, I'm doing metric to metric conversion, okay? And I have 4.28 millimeters. Oh, that's really funky. And then, that's so really funky. What am I? Oh my goodness, I can't do one simple parenthesis. Okay, you guys are probably going to kick out of this right now. Alright, so I don't want millimeters. It's going to go here. And I want meters on top. Now, this is between the metric system, metric to metric conversion. Last time, I put up a table for you. Go back to that page and look at the table that I put up for you. Okay? Now, what I said was that the way to do this, figure out, so for which one is a larger unit. Again, now here I have my millimeters. Millimeters goes down here, meters goes on top. Now, if you look at the conversion, which one is a larger unit? If you look at it, you will see that meters is a larger unit. You put a 1 next to a larger unit. Okay? Now, if you look at that chart, so meters is going to be our reference, is 10 to the 0. Now, millimeters is 10 to the minus 3. Look at that chart. So, we went from 0 to minus 3. How many magnitude is that? That's 3 magnitude, right? 0 to minus 3, that would be 3 zeros. So 1 meters is 1, 2, 3 is 1,000 millimeters. Now here is the problem. The problem is I'm not trying to cancel out millimeters. What am I trying to cancel out? Millimeters squared. Now, can I just square this and get on with it? Wish you could, but no. You cannot do that because these values are not for square or cube. So they're not, the chart doesn't have cube or square, so you can't just get fancy on me and put square on here. The only thing we can do, we can square the entire parentheses. Now, if you do that, you have to be careful. That means if you do that, what that means is the meters is going to get cubed, the 1 is going to get cubed, millimeters is going to get cubed, 1,000 is going to get cubed. Everything is going to get cubed, which is nice because then if everything gets cubed, the millimeters is going to be everything is going to get squared. Then the millimeters squared can be canceled out. And what I end up with, I end up with meters squared. And that's what I wanted anyway. So that works out nicely. Now the math. Remember, since everything gets squared, the 1,000 will also get squared. So it will be 4.28 divided by 1,000 and then divided by 1,000 again. Or 4.28 divided by 1,000 squared. Okay, now I definitely want you to take out your calculator and make sure you do this. Okay, now if you do this, now we have to think about sig fig. Now let me actually give you the answer that I get without the sig fig first. So I get 0.0000428. Okay. Now how many sig fig do I need? I have 3 sig fig here, and I know this has no sig fig, so my final answer should have 3 sig fig, except this number is not really pretty. I wanted to, so this is 3 sig fig, so the sig fig is okay, but scientific notation would be nicer. So it would be 1, 2, 3, 4, 5, 6. So my final answer would be 4.28 times 10 to the minus 6 meters squared. That would be my final answer. So far, so good? Okay. And this is a tiny number. That's why it's going to be minus 6. All right, beautiful. This was a really, really good practice problem. It took a lot of time, but that's okay. I'm going to make sure that you guys are getting these down. Now, the next topic we're going to talk about, we are going to talk about density. What is density? Now, check this out. Let's say I have 2 cubes, and these 2 cubes are exactly the same volume, they're the same size. I haven't go over that yet. This is from gold. So I have these two cubes. They are the same size and they have the same volume. But one is made of wood, one is made of gold. Which one is denser? The gold one is denser. This is going to be a lot heavier. Even though they're exactly the same size, but this one is going to be denser. This one is going to be heavier because you can pack in more gold atoms in a given volume than wood. So that's density. That means mass over volume. Even though these two have exactly the same volume, the same size, but this one is going to be heavier because it's more density, because you can put in more gold in a given volume. So here's what I need you to remember. Density equal, technically our first equation in the class, mass over volume. Density is mass over volume. Density is mass over volume. Okay. Now, there's many different units for mass and many different units for volume. Any mass unit, any volume unit would do. But there are two common density units. Again, I want to make sure they're not the only unit, but there are two common density units. Grams per milliliters and grams per centimeter cube. Okay? Again, these are two common density units. Not the only ones, okay? There are two common density units. So far, so good. Now, one thing I want you to remember, I want to put it in red so you remember that 1 millimeters equals 1 centimeter cubed. And millimeters and centimeter cube, those are the units for volume. Those are metric units for volume. Remember that. So 1 millimeter equals 1 centimeter, and those are metric units for volume. Okay, they are metric units for volume. All right, beautiful. Now, let's do a density problem. Here is a density problem, okay? So read this problem for me. Now, every time you have a density problem, what I want you to do, I want you to write down density is mass over volume. Every time you have a density problem, what I want you to do, I want you to write down that density is mass over volume, okay? Now, once you do that, then let's see what's given to us. In this problem, what we have the density. The density is given to us, okay? So we have the density. And what the question asks us for is for mass. So they ask us for mass and the density is given to us, okay? So ask us for mass and the density is given to us. Now, if the density is given and they ask us for mass, what that means is somehow they have to also give us volume, because you cannot have two variables and then try to solve for it, right? You can only have one variable. So our variable is mass, we have the density, that means the volume has to be given somehow, right? May not be directly, but somehow they've given it to you. And when they give you the density, they give you the unit for density. They said the density is in a gram per centimeter cube. You are locked in that unit that the problem gives you. The problem says the unit is grams per centimeter cube. So I am locked with that unit. I am locked with that unit. That is going to be my unit. Okay. Now, I know that I have density. I know that I need to have volume somehow, and I need to figure out the mass. Ready to do this? Okay. Is volume given to you? Volume is not given to you directly, but they give you the measurement, right? They give you the measurement. So the measurement is 1.3 by 3.8 by 5.9. So think about the algebra back in high school. So could you find out the volume if dimension is given to you? Yes, if dimension is given to you, you can definitely find out the volume. How do you do that? That means, that's you know how to do that. 1.3 centimeter times 3.8 centimeters times 5.9 centimeters. Okay, so far so good. Now, if I do that, what I end up getting is 29.146. And I'm not going to worry about I'm not going to worry about rounding until the very end, okay? We don't round until the very end. Okay, so 1.3 centimeter times 3.8 centimeter times 5.9 centimeters. Centimeters times centimeters times centimeters. So my unit is going to be what? My unit is going to be centimeter cubed, because centimeter times centimeter times centimeter, my unit is going to be centimeter cubed. So now I have the volume. Now I have the volume. You're with me? Good. What is the density again? Density is 11.3. The mass is not given to you. So the mass is X. Do I have the volume? I have the volume. This is a volume, and the unit are right. The unit has to be centimeter cube. The unit is centimeter cube. So what I'm going to write down here is 29.146. Okay? All right. If you do that, what are you going to get for X? You're going to get 329.3498. Now let's think about sig fig. Over here, even though I keep all the units, these are all multiplication. Do you agree? Multiplication, we go with the lowest number of significant figures. 2 sig fig, 2 sig fig, 2 sig fig. So this should have had how many sig fig? This should have 2 sig fig. Again, I kept all of them because if you start rounding early on, by the time you get your final answer, it's going to be so off. But I know in my head, I'm supposed to have only 2 sig fig. This is 3 sig fig. I know this is supposed to have 2 sig fig. So my final answer should have only 2 sig fig. How I'm going to round it? I'm going to round it to 330. What's the unit? The unit is gram. So far, so good. Okay, now I have a feeling I might have lost some people doing the algebra over here. Now, this is cross multiplication. When you equal this is cross multiplication. Then you have to do cross multiplication. So the way I got this number was 11.3 times 29.146. There are no parentheses here. This is cross multiplication. You go cross multiplication. That means 11.3 has to be times 29.146 to get my X. I get my X. My X is a mass, and the mass unit is grams. And I know the final answer should have 2 sig fig. So this is my final answer, 2 sig fig. All right, how do you feel about this? This was a big problem. This was a big practice problem. You guys did really, really well. Okay, we're going to have one more lecture on unit conversion. I'm going to give you more practice problem. I will talk to you guys next time.